Now, we shall compare both EC and IC engines. So, both the engines can be compared in terms of all these parameters. So, size of the engine, mass of the engine, of course, it depends upon the size once again, starting of the engine, thermal efficiency, whether is there any requirement of auxiliary equipment or extra equipment, and the quality of the fuel used and the capacity. Okay, so first of all, if you see the IC engines are more compact or small in size than that of EC engine. Okay, so they are compact in size. They are smaller in size, so that's why occupy less space. So the EC engines, they are larger in size and occupies more space. Okay, so they are larger in size and occupies more space. If you take a TVS XL motorcycle, its engine is very small. But if you take a steam engine, a railway locomotive, it will be as big as our classroom. Is it right or not? So that is the difference in size. Okay, and then coming to the mass, it also depends upon the size. As the IC engine is smaller in size, the mass is also low. So it is low and it is high since it is larger in size. Coming on to the starting, with how much ease you can start the engine. So how can you start a motorcycle? Simply by pressing a button, the engine can be started. By using self motor, simply by pressing the self button, you can start the motor immediately within seconds, not even seconds. But that's not the case with the EC engine. If you want to start a steam engine, in case of locomotives, at least it requires 3 to 4 hours. Why? Because if the engine is completely stopped, you have to start the combustion process. You have to use the coal, you have to ignite it, and you have to produce enough amount of steam to run the engine, and all this process take at least 3 to 4 hours. Okay, so that's why the steam engines are not stopped. When you have to stop the engine for 3 or 4 hours, it will not be stopped. It will continue to run. But it is not the case with the IC engines. You can switch it off and switch it off as and when you require. Okay, so that is, starting is easy in this case, and it is very time taking, difficult and time taking. And coming on to the thermal efficiency. So you know by this time what is meant by efficiency. It is the ratio of output by input. So what is the output here? The work output. What is the input you are giving? The fuel. Is it right or not? You are giving fuel and getting the work output. So the ratio of output to the input is called as efficiency. So for example, if I have supplied say 100 kilojoules of heat, and the work you obtain is say for example 30 kilojoules, then this 30 by 100 is thermal efficiency of that engine. Okay, so here the thermal efficiency of IC engines are higher than EC engines, but here the efficiency is lower than that of IC engines. The thermal efficiency of IC engines is around 30% to 40%, whereas in that case it is around 20% only, approximately. So that is the difference between these two. And coming on to the auxiliary equipment. So in addition to the engine, it requires, IC engine requires certain components like carburetor. I think you might have heard this word, which is used in petrol engines. Nowadays it has gone. In BS6 vehicles there is no carburetor. So carburetor was used once up to BS4 I think. In the present vehicles the carburetor is not there. There also you are using fuel injection system. Okay, so this carburetor is basically used in petrol engines, and then you may use fuel pump or fuel injector, fuel injection system, which is used to inject the fuel inside the engine. So here both carburetor and fuel injection systems are used to inject the fuel into the system, to send the fuel into the system. And here this is used in petrol engines and this is used in diesel engines. That is the difference. So these two are necessary for running an IC engine. But in this case, we need a boiler which is used to produce steam by heating the water. By the combustion gases, the steam is produced. So for that purpose, the boiler is used, and also certain components like condenser. Once the steam is utilized in producing the work in the steam turbine, the remaining steam has to be converted back into the water. The steam has to be condensed back into the water so that it can be again reused. Okay, so that is condenser. So these are the components required for AC engine, and these are the components required for IC engines. And the next one is quality of the fuel. For IC engine, you need good quality of fuel. That means you need refined fuels. Refined fuels are used. You cannot use cheap quality fuels, because here both carburetor and fuel injection system consists of a very small apertures, means small holes through which the fuel has to travel. So if the fuel is cheap, it may have certain impurities which will block the small holes. So that's why here you have to use only refined quality of fuels, but here you can use cheaper quality, because here the combustion takes place somewhere outside the engine. So there is no direct contact between the combustion and the engine. So here you can use cheaper fuels, like even coal also can be used, right? And the last one is capacity. The power produced is lesser in case of IC engine compared to the EC engines. So that's why they can be used for smaller capacity units like our automobiles, and they can be used for larger capacity units like trains. Okay, so these are all the comparisons of IC engines and EC engines in different aspects. So with this, you may answer any question. What are the advantages of IC engines over EC engines? So by observing these things, you can write all the positive aspects as advantages and all the negative aspects as disadvantages.